everyone. Am I audible?
Yes, sir.
Okay. Just a minute. Let's start the session. So today is solve with us, right? Solve with us session for I think week 5 and week 4, right? Okay. So what we can do today is we'll do week 5 first. Week 5 solve with us, and then after that we'll do for week 4. Okay. I hope that is fine. Uh, okay. Are you guys there?
Yes, sir.
Okay. All set, like all tea, coffee, everything is over.
Yes, sir.
Correct?
Over.
Over, na? Okay. I know I was not listening any voices, so I thought everybody is hungry or something. Okay, fine. So I need your participation here so that I will also know that okay, people are there, they're solving or trying at least, right? Any doubts you can ask anytime. No issues with that. So I hope my screen is visible to you.
Yes, sir.
Yes. Could you explain week 4 PA? Yes. Maybe at the end of the session, I will do that. Is that fine? You just remind me. We'll do that. Okay. Are you able to see this code? The code is WAERIT. Okay. So four of you have joined. Others please join using this code. Okay, let's start the class. 13 have joined. Those who are ready to join, you can join by using this code. Go to joinpd.com and write this code WAERIT. Okay, let's start. So this is our first slide. Next one is the question is the length of the complex vector u will be what? Like this is the vector in front of you, 1 plus I, 1 minus I, and 1, and we need to find out the length of the vector. So in general, what is the length of the vector? Square root of, let's say if it is two
Some
element is there. Yeah. So let's say you have a vector with two elements x and y. What will be the length of the vector?
Root x square plus y
Plus
square.
y square. Right. Okay. So yeah, this, and in complex vectors, the length will change or it will be the same.
Conjugate transpose into
Okay.
then number.
Right. Okay, 12 have responded. I'll wait for one more minute and then we'll discuss the solution.
Sir, can you share the link
Link for what?
here? Like
You can link or code you want.
the link.
It is joinpd.com. You'll have to go to uh, Google and okay, I have just shared. You can, or you can, yeah, Utkarsh also have shared, I guess. Or you can Google it, joinpd.com, and then I have actually pinned one message here. So that code is WARIT. So you can join using that code, and you can the code is visible here also. Okay, so now let's see. I think I have 16 of 21 have responded. Uh, okay, maybe we can actually uh, see the solution. Is that fine? So the length of the complex vector is 1 plus I, 1 minus I, and okay, this vector we need to find out. And generally, it is the square root of this, right? Square root of the length of the x, right? So basically, what is the square of norm? Actually, this is called as a norm, right? Euclidean norm, and it is x into x for any vector x, and it is x1 square plus x2 square plus xn square, right? uh, if it is a real vector means all the elements of the vectors are real numbers. In that case, it will be u1 square plus u2 square plus un square. And in the case of uh, in the case of this vector, the complex vector, this formula will be changing. And how it will be changing? So basically, so if in this case we have vector u, right? Is my screen visible? Okay, just a minute. I will try to see the length. I
Sir,
Yes,
are you solving the first question?
yes. My screen is visible, right, to you? This one.
Yes, sir.
Okay. So our vector u is what? And tell me what is the vector? Okay.
So 1 plus I, 1 minus I, and 1.
So is one plus I, one
1
minus
minus
I,
I,
and
1.
one. And this is a complex vector. So the length of the complex vector will be what? And what is the conjugate? Like first of all, we'll understand conjugate. Conjugate of the vector is how will you decide the conjugate of the vector, or how will you write this conjugate of the vector?
Minus.
Sir,
So
we have
One
wherever,
to
minus I would.
find.
yeah, so wherever your imaginary number is there, we'll have to change the sign of the imaginary number. If it is a real number, you don't need to change that, right? So in this case, if you see, the first element is 1 plus I, so it will be changing as 1 minus I. Then 1 minus I will become 1 plus I, and 1 will remain same. So that is your conjugate of u. It's called as the conjugate of vector u. Okay, and the length of the vector now. So length of the vector is basically this is denoted by this, right? So the norm of u, and it will be what? Square root of u dot product with dot
You
product with
conjugate.
its conjugate, right? And let us try to solve. So first of all, uh, okay, we can actually write down the square root, the big square root. Let's say it will be what? Then what will be the dot product of u and u, uh, u hat, or u conjugate?
1 plus I into 1 minus I.
Hmm? 1 plus I plus, I don't know why this is happening, but
Yes, sir.
uh,
You have to take the transpose also. You cannot uh, take the dot product of two matrices of the same shape.
either you can write like this, okay, or
Hmm.
you can have, so when the dot product can be written as, in terms of, if it is a vector, it can be like u transpose u conjugate, right? Transpose u conjugate, right? Just a minute, I don't know the issue here.
So it will be U conjugate transpose U.
U,
Sir, dot product of a complex matrix is complex vector is U Hermitian U.
u
So
Hermitian,
that
why?
So I think it should be U conjugate transpose. No?
Okay, the dot product between
yes,
these two, right? So okay, let us say the dot product between these two quantities. What that will be? If z is a vector, and if z is having your z1, z2, let's say z z3 up to zn, let's say, or z3, and w is w1, w2, w3. These are the elements. What will be the dot product here? It will be z1
Transpose.
into z, or z1 conjugate plus z2 conjugate plus z3 conjugate, right? Is that fine? Or like, it's not dot product here, it is like the multiplication, right? Is that correct? The length of u is basically what? Or length of any vector is what? Hmm?
Real or complex, you're asking?
No, no, complex, complex. Let's say you have this, right? So 1 plus I and 1 minus I, right? So we'll have to multiply that, correct? In a complex scenario, what that will be? And now I wanted, so you have two vectors here. U is one vector, and there is, like, you wanted to find, basically you wanted to find the square of it, right? Or I can say that, let us say, what is the length of the vector? So the length will be equal to what? Or length of u will be equal to, uh, right? Kind of like that, or what is it? Let's say u dot u, right? All of you know this part, right? I don't know. Whether
Yeah,
it
yeah,
is.
we know this, like this.
Then how will you solve this part? Like, for this question, what that will be, like, if you wanted to find the length of this, what that will be?
Plus 1 minus I into 1 plus I.
Okay, let us. I'll just one plus I into 1
1
minus
minus
I
I plus
plus
1 minus I
1
into
minus I. 1 plus I plus 1
plus
into
1.
1.
right, or 1 into 1. Let's say. Okay. Is that correct? So what you
Yeah.
have done here is just that you dot, or you're done the multiplication, right? Because this was your complex conjugate vector, and you just have multiplied that, and what that will be then, the answer will be, so let us try
5.
to find out. So for this part, it is 1, like a square minus b square, so it will be 1 minus
Minus I square.
I square plus, again here
1
1
minus I square.
and plus 1, right? And I square is minus 1, so
Minus 1.
this will become 1 plus
Sir,
1
this
plus 1.
problem, sorry to interrupt. If we do
Yeah.
it like this, that the first two row are having the complex component to it, complex number.
Hmm.
So if we take the first two row and then multiply this with the conjugate of the denominator, then it is coming as simplified I, only I. And then we are remaining with u is equal to I and 1. That is the vector. And then the calculation becomes easy actually. But whether that approach is okay to follow.
No, I don't understand like what you are saying.
The first two row,
Yeah, let us say you have u. Basically, you
uh,
have only this part, right? 1 plus I, 1 minus I, and 1. Right? Okay.
correct,
What do you
correct.
want to do now?
So in the first two row, if we take 1 plus I by 1 minus I and then multiply by conjugate of the denominator.
Divided by 1 minus I.
Yeah, this is there, right? And then this one, we are multiplying this by 1 plus I.
Where, but how you are dividing
Like
this?
this is conjugate of the denominator.
But where this denominator comes from? That is what I'm asking.
To can we simplify this if it is having a complex component to it?
Oh, you're just saying that if you have like this number I,
Ah,
what you do generally is that you wanted to make it like you want to do like this, huh?
correct, correct. So simplify that part alone separately and then proceed with the calculation rest of it.
Okay. But then I, I don't think like I don't know whether that is the correct approach or not. But because simplification, what for what purpose you do simplification?
I think
Uh,
he is trying to rationalize it so that
yeah,
it come out to be like a real numbers.
real numbers, right? I
Yes, yes.
understand that part, but I don't know whether we can work out here
Sir,
because
but rationalize will do for irrational numbers, no?
correct, correct. That is what I'm saying. Like you should have that first, right? You cannot make like minus I into this, no? So okay. Generally, how it will be done is like this, no? Let us say you have one upon I as the number. What do you do then? Then you multiply with the minus I and minus I, right?
Correct.
And then you have minus I above, and then here it will be minus I
Minus
square.
I square, that will give
Minus,
plus 1.
yeah, minus I divided by let's say 1. So that means it become minus I, right?
Yes, yes.
But this will be done only when you have the denominator as the complex number, right? But here
Mm.
you do not have the denominator, right?
Mm-hmm.
Then we cannot do it, right? You're understanding the point.
Yeah,
Like
okay.
rationalization is done only you have some complex number in the denominator. Let us say you already have this number, right? Then what
Mm-hmm.
you do? Then you just multiply above and below by minus I, and now this will become minus I 1 plus I, and here it will become 1, and then this will become minus I minus I square, which is again plus 1. So minus I plus 1. Basically this will be, so this quantity will become, I can write as 1 minus I, but here in our vector it is not there. So the approach here is to do what? You just multiply with its complex conjugate, right? Because you wanted to find basically square root of u square, and that is in complex terms. How it will be done? We'll have to write like this, correct? The dot product between its conjugate and the,
So conjugate transpose.
yeah, transpose you will use because I have used the dot sign here, right? If I remove that, so let's say you have two vectors a and b, the dot product between two vectors is represented by this, right? And how it will be written in terms of linear algebra? It is a transpose b, right? So these both are same, correct? So either I will write uh, conjugate of a, sorry, u into u, or I can write like this, correct? So how will you solve this part is like this. So u conjugate is what, and what is it? Okay, okay, first of all I'll write down the conjugate part. So sorry. So the conjugate part is, what is it? 1 minus I, 1 plus I, and 1, right? This is my conjugate. And how will I write this transpose? U conjugate transpose, it is 1 minus I, 1 plus I, and 1, and you will multiply that with uh, the u vector. So 1 plus I, 1 minus I, and 1, and then you solve this. So this is vector multiplication. And how uh, then what will be the values then? So this will become 1 minus I into 1 plus I plus 1 plus I into 1 minus I plus 1, and then you will get the answer as 5. This thing you can write it like this: the dot product. Both the things are same. The only difference is nomenclature, right? So when I write like this is also same as this. But when I write like this, that means we are doing the vector multiplications. Okay, fine.
So don't we have the
So,
square root?
Sorry.
Square root?
We, yeah.
sir, can't we take square of each one and then add them and do square root?
uh, in 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 this complex numbers, you so how will you do the squares, right? This is a square only, right? This each element square only. But the
Yes.
thing here is it is complex, right? So square will become the conjugate of that element. You understand? So let us say you have this 2, 3, and 4. So how will you do that? 2 square plus 3 square plus 4 square, and you take the square root, right? If it is the real, if all these are the real numbers. So
Yes.
basically what you have done is 2 into 2, 3 into 3, and 4 into 4, and then you have added that. But if these will be the let's say complex numbers, right? Let's say 2i, 3i, and 4i, then this will not be like 2i into 2i, correct? Because what will happen
Yes.
then? Let's say if I do 2i into 2i plus 3i into, or maybe let's say 3i square, or if you want to do 2i square and plus 4i square, what will happen then here? What is 2i square? 4i
Minus.
square, or yeah, okay, maybe if you can know that minus 4, then this will become minus 9, and this will become minus 16. So the total will be what? 29, minus
minus
29,
29.
and then it will be square root of minus 29, and then it will be a complex number, correct? But that's not how it is done, because when you do the dot product, uh, it should be scalar, like it should be real, right? Anyway, your and this is not how it is done for complex numbers. For that you need to do like 2i times minus 2i plus 3i into minus 3i plus 4i to minus 4i, and then now your answers will become different. So this will become 4, right? Then 9, and then 16, and then this will become root of 29. I hope you understand that part.
Yes, sir. Sir, but why is that wrong? Like, did they define that the dot product answer should be only real?
uh, See, the thing is the dot product in complex scenario, this is like, this is what like mathematicians, who are there, right? So they have come up with that, we have to follow those rules. These are the rules for doing the complex dot product. So because this is complex or imaginary number, right? uh, it is a different. So in real case we have dimensions which are the real dimensions and when it is complex numbers, right? So there are some different rules associated with that. There's like it's not like right and wrong. The rules are there. So these are the rules how you should do the multiplication of two complex numbers. Fine.
Okay.
Yeah.
Sir, but under root is, I mean, only 29, or sorry, the answer is only 5 or under root 5?
Under root 5, because we have asked the length of the square, length of this, right? So length is square root of the that Euclidean norm square, right? Correct. So answer is root of 5.
Okay, sir.
Root of 5. Okay.
Sir, this one, even though if it is not a complex vector, same way we calculate if it is a real number also.
Yeah, we can do.
Same thing like
Correct, correct.
here.
So, but for real numbers, the complex conjugate will be that number itself, right?
Yeah,
So,
yes, yes.
and that's why the answer won't change for that. So, like if you apply this rule, let us say you have 2 and 3. So, what is the complex conjugate of 2? So, let us say a equals to 2. The complex conjugate of a is 2 only. If it is b equals to 3, the complex conjugate of b is 3. But if it is a equals to 2i, then the complex conjugate of that a is minus. So if you apply the same rules, right, for the real numbers, you'll get the same answer. Because then it will be 2 into 2. So it is equal to 4. Positive. Okay? Sure. Okay, let's proceed to the next question. So the length of the complex, we have to find out the length of the complex vector u scaled by a
Also,
scalar.
there was another question in the previous one. It was
No, no,
asking
no,
you
no,
are to.
that was a solution.
It's
Okay, at the end,
about
length of the complex vector and its conjugate remains same. Is it true or false? That was the question.
false.
Right? It will be different. Okay. The second question here is the length of the complex vector u scaled by a scalar. So basically, what you wanted to find out here?
Sir, that true or false question.
We'll do that. We'll do that after some time. Just finish this
Okay.
first. It is nice. It is like uh, it is a corollary to what we have done right now, but it's fine. We'll do that later. So it is 1 plus I, 1 minus I, and 1. So this was my vector. There is one scalar eta, which is 4 plus 3i. You have to find out the length of this vector, eta u. Is that fine? That is the question.
Why did it say scaled by a scalar? Scalar can be a complex number as well, is it?
Yeah, yeah, yeah. Because we are actually working in the complex or complex system, right? Complex coordinate system. So it is possible.
Excuse me, sir.
Yeah.
What is the answer for the first question, sir?
Root of 5. Root of 5.
Okay.
But sir, in that solution, what you had, it is 2.23. That is correct answer, no? Why
Correct.
we?
It is root of 5 only, right? 2.23. 2, see, you just see that in the square root is 2 plus 2 plus 1. What is it? Root of 5, right?
Yeah, this is correct. But the length of the complex vector and its conjugate remains same. This part I am asking. The length of.
No, that is a different question. So this is a statement that the length of the complex vector and its conjugate remains same. Is that true or false? That is a question.
Oh, okay, okay, okay.
Okay.
So this one, when it is talking about a scaled by a scalar, this, then it is that eigenvector and eigenvalue here. Here this is eigen value, right? It is getting scaled by this. Am I right in this understanding?
Sir,
Huh.
so what does this mean? Scaled by the scalar.
So let's say you have any vector, right? Think about in the real space. If you have one vector, and let's say the vector is u, and if I say 5 times u, what does that mean? Huh?
Sir, I
Length is
multiply.
this vector.
So let us say you have one vector u. Okay. If I say 5u, where that will be?
Length is from here.
So it
Extend.
will be elongated, right, or extended. Let's say this is a 5u vector, right? If I say point 5u, what does that mean?
Half of
Reduce.
users.
Half of the vector, right? So this is the point 5u vector. Is that fine? So like this, you have scaled this vector by, let's say, and when I say 5u, what does, again, suppose your vector is 1, 2, 4. Point 5 of u is what? Point 5, 1, and 2, right? 5 times u is how much? It is
5, 10, 20.
5, 10, and 20. And what is the length of u? It is square root of
1 square
1
plus
plus
2
4 plus 16, right?
16.
And what is the length of point 5u? It is square root
Point
of,
5 into
yeah. So you can say that it is like point 0.5 square plus 1 square plus 2 square, or you can say that it is like,
0.5
uh,
root over 21.
sorry,
0.5 root over 21. 0.5 is
point
the length of
0.5 times length of
root
u.
over
Is that
21.
fine? Or I can say that point 0.5 times square root of 1 plus 4 plus 16. Is that correct?
Yes, sir.
So that is what. So similarly, you have this scalar here. Now this is not the real valued scalar; it is a complex valued scalar. So what you have to do is you will have to multiply, or you can take this common out and find out the length of this vector. We already have found out length of u in the uh, previous question. You just have to multiply
Yes,
that
under
and get it. Yeah. Right. So like that, you just try it, and I'll show you the solution. Okay. So I'll just wait for 1 more minute, and then we'll see that question's answer.
Excuse me, sir.
Hmm.
So when we say the scalar eta equals to 4 plus 3, that means the length of this scalar or the length of this vector from 0, right? Origin.
But no. Your question is something. I don't understand. You are trying to say something different, I guess. What are you
When
trying to
4,
say? Ah,
yes, sir. I mean, when 4 plus 3 iota, that means the distance of the in vector or the complex space,
huh.
the distance of point 0.4 comma 3 I from the origin, right? The
4
scalar
comma
eta means,
3
no?
I.
Uh,
Uh,
in complex space, it becomes 4 comma 3. Sorry, 4 comma 3, right?
but then, okay. Okay.
Then converting it to scalar will be the distance of this point 4 plus 3 I from the origin, right?
I think yes. Yeah. Correct. That is fine. That is okay. So basically, you have this two. Uh, this is like different thing. Okay, it's like,
Distance formulas are in imaginary
correct.
space, right?
That is your whatever you're saying is correct only, but the way you are describing it, it is not, uh, because this is not scalar thing, right? It's a different actually scenario. If you think about it, like if I wanted to say,
Uh,
let's say, 1 minute, I'll just try to explain
So
this.
this is the distance when we're talking about unit length or distance. So that is the distance. Na? Length is the distance.
Length is a distance. Yeah, that is true.
Uh, so
But
when I
let's
say talk,
say, let's say your vector is 1 plus I, 1 minus I, and 1. So this vector already have three different dimensions, right?
right,
It is having three dimensions, but
right.
each of that element here, it is again in you can say in two dimensions, right?
In plane, sir. It lies on the plane of some light.
So visualizing all of this, right? It is not. I can say it's not that easy. But if you just wanted to visualize this 4 plus 3i, then it is
Hmm.
right, because one plane is, let's say, real plane, and one is imaginary, right? Or
Hmm.
vector, or let's say it's two dimensional. So if
Hmm.
I wanted to find out this point,
Hmm.
so that will be a point, kind of like this, right? 1, 2, and
Hmm.
3, 3 in the reals, and 1, 2, 3, 4, 4 in the imaginary. So somewhere like this. So this is correct. This 4 and 3i, right?
Hmm.
But now
Right.
if I wanted to see this also, and if I
Hmm.
try to multiply, basically what you are doing here is you are trying to multiply reals with reals, and imaginary with imaginary, kind of like that.
Conjugate, sir. 4 plus 3 iota into the conjugate of 4 plus 3. I'm doing the complex multiplication only.
For no, 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 you don't have to do that. What you're doing like this, huh? 4 plus 3i and 4 minus 3i, is it
That
like
is
that?
the this norm, na?
But it is not. Okay, I guess you are confused. Okay, let us say you have, I just showed you one thing. Suppose you have one vector u equals to 2 and 2 3. So let us say this is a real vector, right? So where is this point, or where is this vector actually? So it's x is
2,
2, and y is 3. So
3.
can I say this is the point? Now this is
Hmm.
the vector u. Is that correct?
Right. Right.
Now if I say 5 times u,
Hmm.
so where that will, or let's say, okay, 5 will be like too much now. Suppose I
2
say it's
times u.
2 times u. Yeah. So 2 times u is what then?
Double of this.
4 and 6. And if I wanted to showcase that, that will be, let's say, now it is like, okay, 3 and 4,
4
and here it is
and
4, 5, and
4, 5, 6.
6. So can I say that this is the vector?
Hmm.
So when I multiplied that 2 with u,
Hmm.
what I have done exactly? So this 2, what you've done, you thought of it as a scalar. What you've done is you have elongated this initial 2 on x-axis by 2 units, right? So
Right.
you have multiplied that 2 units on x-axis, and you have multiplied 2 units, like 2 times into on the y-axis, right?
Y.
X and y-axis. Similarly here, it is, if it is 2i and 3i, right?
Hmm.
Now 2 plus I and 3 plus I. So 2 plus 3i is one point in like complex system, right? So
Hmm.
think of that on x-axis. Let us say it is 2 plus I, and
Right.
now 3 plus I is on y-axis. Let us say. Hmm?
Right.
Suppose somewhere here. Now what I'm saying is 4 plus 3i is a
Hmm.
scalar. Its entire thing
Right.
is a scalar. So I'm
Hmm.
multiplying this 2 plus I with 3 plus, like 4 plus 3i. So I have to
Hmm.
move that element by this much on x-axis, and
Right.
move this 3 plus I by
4 plus
this element on the y-axis. But what you are doing here is you are actually finding out the scalar's length. This is a scalar, right? So you
Hmm.
will not be able to find out its length, right? Yeah,
No, we can, na? Scalar
how?
is that, na?
No, scalar does not have the length. No, vector will have a length, right?
Scalar will have an
Scalar,
absolute value.
So does
scalar is a number.
Sir, scalar will have length but no direction, no?
yeah, that is, yeah, okay.
Hmm.
The length means like what is it?
Magnitude.
Like it's only
Well,
that
there is no
length, right?
length.
Magnitude. No
Magnitude.
direction, only
Magnitude.
magnitude.
Magnitude you can say, right? So when
Hmm.
I say length, length is the specific thing which is for vector only, right?
Hmm. Right.
So
Yes,
uh,
yes.
magnitude is a different scenario than the length. Length is like kind of I'm at one point and I'm going to another point. What is the length between these 2 points? But when these 2 points are in the space, so these 2 points separately define the vectors, right? Like let's say, and now we are finding out this length. It's okay. It doesn't matter anyway.
And
That.
Sir, this
so one more
problem.
thing, sir.
Mhm.
Just one more thing, sir. If I have to find the length of, or the norm of 2 plus iota, only one point. So how will I find it?
Yeah. So that is, in that case, let's say 4 plus 3i was your one point, right? And now you wanted to find what is its length. So length means, again I will say that magnitude only. So that will be like the same way you just said. So it is kind of like this. We will have to multiply with its conjugate. So generally, and again you will have to take the square root of it, right?
Right.
So that will be your 16. So basically it's a square plus b
Five root
square.
five, sir, is 5.
So yeah, so that is 5. So basically it is kind of looking at like this. So we have 4 plus 3i, that means 4 units on real axis, right? And let's say 3 units on imaginary axis. Now this is the point in that real imaginary space. Now you wanted to find out what is its length, right?
Right.
So basically what you do is you just say that now it will become Pythagoras theorem, right? So this is 4 units on this axis, 3 units on this axis. The square root of 4, 16 plus 9, which is 25, which is 5. So the
Right.
hypotenuse will be like this. Okay.
And sir, if I talk about the vector, suppose that the vector you have written on just the above image above it, no, this explanation 2 plus iota. If I have to find the length, so that will also be in a similar fashion.
Yeah, yeah, but you see, I just
It's a
to
vector.
try to show you, but this is not like that, no. When there's 2 plus I, when I write, basically that will be a different point in this space, right? So it is like that, no. Let us say, I don't know. Okay, actually, see, imagining all of this is not that easy, because U is a vector which contains 3 elements, right? Let's say 3
Right.
minus I and something. So first element is okay. How many dimensions does U have? If I wanted to say that, how many
3.
dimensions does it? 3 dimensions. So, and
Right.
how that each point will have? Okay, each point will have again its two dimensions, no? So I cannot actually represent that on this 2D plane, which I'm having currently, right? I can just say that, okay, let's say if it is the real number, so real axis, and if it is the imaginary axis, one point is, let's say 1 and 2 and 1. So this is one point, which is 2 plus I, right? Basically
Right.
it's not 2 plus I also, it is
2 comma 1.
2 comma I, right? So 2 comma I and 2 plus I again is
2 comma 1, sir.
1, yeah. Because when I say, okay, but I don't know, I am not able to draw this, because this will be like, this will become very weird, no. uh, yeah, but
So
uh,
what's the question actually?
question was not this, that so he
No, no. What's the doubt?
doubt is that I think he was multiplying that scalar, or he is separately finding out that length of the eta, and then I think separately finding out the length of u, right? It's kind of like that.
Sir.
Scalar
Just
has
multiply.
So
scalar has an absolute value.
what he was telling is like it will be norm of u and norm of eta,
Eta.
that eta, and that will give
Multiplied
the
with,
answers. Yeah,
yeah, that should give you the answer, right?
yeah.
Anyway, that will give the answer, because the same thing you are doing anyway. Because I think I have showed you one thing here, no. I think that answer, this one, this thing, right? This was scalar. So you're actually finding out square root of this, and then square root of u, right? Like long. So 0.5 into this, kind of saying like this. So you can actually find out the answer by finding out this. This is also the valid point. Another thing is, you can multiply with each element and then find out this. I'll show you both the answers, okay?
So first one is easy because that is
Yeah,
how.
yeah, yeah. Yeah, that is okay. The different ways are there, but they are not like wrong. So I'll just show you the ways. Whatever is suitable for you, can find it out. What is u? Can you tell me one more time? 1 plus I, I think.
1 minus I.
First is 1 minus I.
No, first is 1 plus I.
Oh, first is 1 plus I. Okay. One
Let
minus I
me
and
check
1.
once.
And eta is 4 plus
4
4
plus
plus 3.
right. So basically I wanted to find out this, no? So I can do one thing. I can actually multiply eta with u first, right? And that will be like, how do you do that?
multiply each
Multiply.
element with 4 plus 3. Right?
So it will be 4 plus 3i into 1 plus I. Do you do conjugate here?
Should we? No, right?
No.
No, sir.
No. This is not a dot product, right? It's just a multiplication. So we don't have to do it. Okay?
Sir,
Yeah.
so we can also take that scalar option. No? It becomes
Correct,
absolute
correct.
value of n
Yes.
times the norm of u.
Yeah, I'll show you that also. Both answers. So
Oh,
this is what now? Uh, 4,
4 plus 7i plus 3i square.
4 plus
7 plus I.
huh?
7 plus I. 7 plus I.
7 plus I. How can it
Yes.
be 7 plus I? Okay, let me
Sorry,
do.
sorry, sorry. 1 plus
So
7.
that
Sorry.
becomes minus 3.
1 plus 7i.
No,
1 plus
let me.
7. Sorry.
So it is 4 plus, let's say, 4i plus 3i and
Correct.
plus 3i square, right?
Yes.
To be like this, then it is 4 minus 4i plus 3i minus 3i square, and here it is 4 plus 3i. Okay, and if that will be correct, then it is like so this will become minus 3. This part becomes minus 3. It is will be 1 plus 7i. This part become plus 3, so it will become 7 minus I, and it is 4 plus 3i. So this is my vector eta times u. Now I wanted to find out its length, and that
Oh,
will be square root of
1 plus 7i square
square
plus,
or complex conjugate, right?
yeah,
Plus
okay.
7 minus, oh, sorry, that is correct, right?
Yes,
Because
yes.
in complex plane you don't do square directly. 7 minus I, 1 plus I is 4 plus 3i into 4 minus 3i. Is that okay?
So
And
for
then
the first problem, we did this calculation, right? Why we took at that time that direct square?
no, we didn't do, no. The first problem also we didn't do direct square. To recall it, it is
The solution given.
here it is 1 minus I and 1 plus I.
No, the solution PPT you shared, right? In that it is done like that, no?
No, there also it's not there, but it is not explicitly written that way. But it is. If I'll show you that also.
You see here how it is. I mean,
No, written is different. So you can see here it is like you can see that absolute thing right here,
mhm.
upward of u1. So basically it has been done like this. Otherwise it will not be. So 1 plus I square is what? 1 square plus 2i plus I square, right?
Mm.
And then it will not be the correct thing.
Okay, I think okay.
Okay.
Yeah,
It
yeah,
is not
okay.
explicitly written. That's why you felt like okay, but that's not the case. This was done like this only. So a square plus b square. So it is a square minus b square, right? Uh, so 1 minus 9i square. Oh, sorry, 49. Plus 49 minus I square plus 16 minus 9i square, right? And then it is 1 minus it is plus 49 plus 49 plus 1 plus 16 plus 9, and that is basically how much it is. 50, 50,
125,
100,
sir.
100 and 125. So square root of 125 is how
5
much?
root 5.
Yeah, pi root
5 root
5.
5.
5 root 5.
Okay, and now I'll show you the other way, which is you can do separately, and we have no that what is the
This is a property, right?
yeah. So what is it's basically same, no? Like yeah, you can say
Yeah,
Like
basically same, but first
norm
one
of
we already calculated as a 5 root 5.
norm of A dot B is norm A into norm B.
yes. 4 plus 3i and 4 minus 3i into what is it here? We already know that this was root of 5,
Root
right?
29.
Root
Root 5.
5,
Root 5.
correct? The previous question. And now this will become what? 16,
5.
Plus 9.
9, or Do I need to do the? It's fine, right?
नहीं नहीं सर, it's the famous Pythagorean triplet ना,
Correct. Correct.
4 3
So
5.
this one also, that yeah, what he said and what I was saying earlier, it is same, right? Even though you don't
Yeah,
multiply
yeah.
this,
Correct, correct.
yeah,
You don't
okay.
need to. You don't need to actually multiply,
Yeah, yeah,
because
yeah.
that way the calculation become easier. You don't need to. So if you do multiplication, then you'll have to write all of these terms, right? You don't need to do that. You just separately find out the lengths for each of that, and maybe like if it was scalar, then you find out its magnitude, and then you just multiply with that.
So
Is that
this
fine?
here also, instead of saying that this multiplication, we would have directly told that 4 square plus 9 I square.
Hmm.
That way also it will give the right answer, right?
4
नहीं
square,
4,
9
no no,
square.
4 square
minus
plus 9 I square.
minus 9 I
No, no.
square.
Then it will see the 4 square
Mm-hmm.
minus 9 plus 9 I square. You are saying, right?
Correct. And it is in the mod.
That is
Minus
okay, but still this quantity
Uh,
I square is minus 1, so it will become 16 minus 9, which is 7. No,
so
right? It should be
no,
a square
no,
minus b
because we
square.
are taking it in the mod, so it will always give the positive, right?
नहीं, but the
It
formula is
is
different
not
ना भाई.
about the
Okay, 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 okay.
For
positive.
complex to conjugate ना, we multiply with conjugate ना for
Yes.
complex. And surprisingly, I read somewhere that we do it for the original numbers, but because of zero conjugate ना, so it doesn't affect. Otherwise, we do it for the real numbers too.
So real
Correct.
numbers, basically, if you wanted to represent into complex number, is how it will look like. I'll tell you.
Zero,
So
zero iota,
yeah, so if this is the 2, right, in real case, so I can say that it is 2 plus
zero.
0 I. Now if you wanted to do the complex, what is the complex
Two
conjugate of
minus
that?
two minus zero iota.
2 minus 0 I. So now if I multiply this 2 into complex conjugate, it is 2 plus 0 I into 2
Two
minus
minus
0 I, and basically it is 2 square, and you can see that it is 2 square
four.
uh, minus, let's say, 0 I square, but again it is 0 times minus 1, right? It is like 4 plus 0 times 1. Hmm? But 0 times 1 is 0, so it is 4. That is why in reals you will get like this. But if you have complex numbers, so let's say only I is there, then here the answer will become like this.
That's it. I mean, for zero we do, but because of for
Yeah.
real we do also conjugate, but because of zero imaginary, so it doesn't affect it.
So yeah, you can do like this differently, so you can see the difference in the uh, signs, right? So when I say the length, so the length of the u is Euclidean norm, right? The two lines, and eta was the square, sorry, a scalar, so it was like written in this format. But the calculation you have to do is you have to multiply that conjugate of that scalar there. Is that fine? I hope you understand the difference here in the scalar and the vector.
Yes, sir. Got it.
Yeah. Okay. Now check whether the two vectors are orthogonal. What is the condition of orthogonality?
Dot product is your
The dot product between the two vectors is equal
Zero
to
should be zero.
0. If it is equal to 0, then they are orthogonal to each other. Now do it for
Zero.
this. Yes. Someone has raised the hand. No, right? Okay. Okay, I'll wait for one more minute and then we'll see the solution. It's easier. Those who are not tried yet, you can try it out. Good to see. So yeah, half of the people are saying that yes and half are saying no. Let's see what is the correct answer.
So here, when we multiply, the order is not important, right, sir? I tried
Order
to.
is not important, but the thing is, you'll have to, you know, what you have to do. You'll have to multiply the conjugate of the other, right?
Yeah.
That
So
you'll have to
only,
do.
yeah, only any one we can conjugate.
Yeah.
Okay. So if we take a different
No, see,
combination.
let's say A dot B is equal to A transpose B conjugate. Okay.
Hmm.
B dot A is B transpose A conjugate. So it cannot be like, uh, you understand. So these two
Yeah.
only are possible. The
Yeah.
the other way around will be the different answer. So let us say if it is A dot B, then you can say that A conjugate. Let's say I am writing it in terms of linear algebra. A transpose B, right? Or you can say like this, A, okay, and B dot A is what? Is that fine? Is that okay?
Transpose. Dot A. Okay.
I,
Yeah. Correct. Correct. Got it. Yeah.
dot then it's fine. But you cannot write like B dot A as uh,
A transpose.
A conjugate, right? Or B transpose A conjugate. Then I think the answers will be different. You may try it out. We can just, let's say, simply I'll show you. A and B is, let's say, I minus I. So what will be its dot product? A dot B is, I can say 1 minus I and I minus I. Right, so this will become I plus I square. Is that okay? Yeah. So it will become 1 minus I, right? This is 1 minus I. If I say B dot
Is it?
A,
Um,
B dot A is minus I plus I and then 1 I. Then this will become minus I plus I square. So then it is 1 minus I. Okay. It cannot be like this, what I showed here. This is not possible. Like I use, let's say, I and minus I. I'll take the conjugate here. So the conjugate of that will be, so this will become what? I plus I square, which is 1 plus I. And this is different than this two, right? So whenever you take a dot product, you'll the conjugate of the first vector, right? Multiplied with the second vector.
oh, so we
Excuse
have.
me, sir.
Ah,
Sir, A dot B, the answer will come as I minus 1, right, sir?
I minus,
1.
no.
Because I square is minus 1. So I minus 1.
So this is I, yeah. I is I plus I square. Okay. Then here 1, 2, 3. Then this going to be wrong, right? No, this is not also possible. I, here it is plus I square, so it is I minus 1, or yeah, I minus 1. This will give me different value, which is 1 minus I. So I think when you do this A dot B, it always be like A conjugate B, right? I think the other way around is not correct here, unlike the case of real numbers, right? So in real case, the dot product is commutative, right? So A dot B is basically B dot A, correct? Now, all right, all right. Okay.
Yeah.
So shall we see the solution for this part? Okay, then here. Can anyone of you tell me the?
So, sorry, I missed. What was the
No,
result of the earlier one, sir?
don't, I will tell you here. Uh, can you tell me the vectors given here?
No, if you have already solved, it is fine. Solution answer should be.
I'll tell you the answer. I do not have the answer. I'll have to solve it.
Oh,
I 31. I 31, right? I 31. Y
three
is
one. I
I01.
zero one. I zero one.
so we have to find out, right?
Yeah,
Minus I 3
three
1.
one.
Here it is I 0 1. So what I'm doing here is I'm writing like this. This conjugate transpose is y, and here it will be minus I square plus 0 plus 1. So here 1 plus 1, it is 2. So x and y are not
Not okay.
right. Okay. And other way around, how was it? Say you have done this first. So that will be minus I 1, I 3 1,
Three one.
minus I square plus 0 plus 1. Again it is plus
Two.
minus 2. So these are correct. So they are not orthogonal. These two vectors will be orthogonal when the dot product between these two was equal to 0. Fine. Find a unit vector that points
So,
in.
so yeah.
Yeah.
Um, can a case occur where one is zero and the other is not zero?
I don't think it will occur. Otherwise, it is very difficult to, because if the two vectors, right? Anyway, you think of this as two vectors, right? If
Yeah.
if they are perpendicular to each other, however you go from one to another vector, right? So you know the dot product, right? So you'll
Yeah.
have to swap, like, and the angle between these two vector will be cos theta. So
Yeah.
generally, if you go from one vector to another vector, that should be giving me as a zero. I think that has to be there.
Okay.
I don't think that will be the case.
I was also asking from the exam point of view. If we get one of the values, we need not
Zero, yeah,
calculate.
yeah.
Yeah.
And I agree tell that. Yes.
The earlier answer was no, right?
No, no, they are not orthogonal. For the question number 3, they are not orthogonal. We have to find out the unit vector that points in the opposite direction of this vector. So which vector will be the opposite to this vector?
It will be perpendicular to this, right?
No, 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 not perpendicular. Perpendicular will not be. The vector has to be 180 degrees, right?
Yes, yes,
180.
180 degree in a complete opposite direction. So I'm thinking,
Perpendicular 90 degree actually, right?
yeah,
It is
yeah,
not like that. So
yes, yes.
opposite direction means if it is x, then what generally what will be the negative minus of x, right?
Hmm.
So you'll have to find out first minus of x and then find out its unit vector. And what will be the unit vector for any x
Divide by norm.
divided by norm of its length? So two things you have to do it here first. First of all, find out the negation of this vector x, and then find out its length and divide it by that length of this vector.
Sir, here negation means a conjugate.
Not conjugate. Minus of.
Multiply by -1. That's correct, right, sir? -1 into this vector.
Yes, yes.
So what's the solution for this
For which question?
third one?
Huh? This one?
Third one.
Third one is no orthogonal. They are not orthogonal because the dot product between those two vectors was coming as 2. It should be coming as 0, right? So the answer to
Yeah,
that
okay.
question was no.
Uh, Sir, how
Yeah,
to answer this?
yeah, I'll let you know.
And how to type,
Type the answer.
type the whole vector?
I don't think, right. Oh yeah, I think. I don't know how
Ask
others
me to
have.
type.
Yeah, okay, okay. You can type the answer.
It is a vector. No?
Yes, it is vector. Is it not possible? I don't know. Others have already responded. I see that how. Yeah, you can write like this. Different answers. Shall we discuss the solution? Okay, I'll do that. Okay, so the question is next. So can anyone of you tell me this thing? So whenever you are working with complex numbers, one thing you will have to understand is what? Which one? About the complex conjugate thing, right? So all the concepts are actually similar as that of the real numbers, but only the complex ones will have the issue, right? Complex conjugate you'll have to remember every time. Okay, just a minute. Okay, got it. So can you tell me the vector x is equal to
1 minus I,
1 minus
1
I,
minus I,
uh,
3 plus I,
3 plus I,
2,
2,
2 and 1 plus I.
uh,
No, 1 plus I.
1 plus. Okay, right. So we wanted to find out its opposite vector. So the opposite vector will be minus of
Sir, one
x.
question.
Yes,
So it is just the opposite vector, right? Will the magnitude be the same or
magnitude will be same magnitude. The direction is different. Let's say you just imagine this. Let's say u is this vector. What will be its opposite vector?
Image with respect to
negative?
x.
This one. So the length of this vector and this vector will be same,
Yeah,
right? Only what is the difference? The direction is different, right?
correct.
So same case is there with the complex vectors also, right? So this is your uh, opposite vector, right? And that will be minus 1 plus I minus 3 minus I plus 2 um, minus 1 minus I. Is that fine?
Sir, it will be minus 2, right, sir?
Sorry, minus 2. Sorry. Minus 2. Okay. Now the next question is we have to find out its unit vector. So let's say if you have any vector A, the unit vector will be what? A divided by its length, right? Or norm of A. That is your unit vector. So it is denoted by A hat. So this is a unit vector. We have to find out the unit vector for X. So basically, uh, okay. Can I say to this as minus X as, let's say, Y? Will that be okay? Say that it is equal to y vector. So now I want to find out first length of y, and that should be equal to what? Y conjugate
Minus 1. Yeah.
by square root of, correct? So in terms of the vectors, how will I write this? Minus 1 minus I minus 3 plus I minus 2 minus 1 plus I multiplied with this minus 1 plus I minus 3 plus I minus 2 minus 1 minus I. Is that okay? Hmm?
Yes.
Yes, sir.
So the multiplication will be like this: minus 1 minus I.
Excuse me, sir. In this case, don't we need to write the square root?
Yeah, square root is there. So
Okay.
I'm just, since it is like this, let us say I will try to do it like this first. Yeah, and then we'll take a square root. So writing square root like to this is like kind of, it will not look good, right? So yeah, okay. Is it fine that if I can directly do these calculations? So basically it is a square minus b square, right? For every term.
Yes.
So I'll just, I hope all of you understand that, and then I'll just, so this is like this one term a, let's say this is b. So so not sorry, oh sorry, I can say that this is a and this is b, and here it is a and here it is minus b. So it is kind of a plus b and a minus b, kind of like that, and it will be a square minus b square. So this will be a square is 1 minus b square is like this, plus a square is 9 minus I square plus 4 plus 1 I square. Is that okay? Then we'll have to take a square root of that if I wanted to find length of y. That is equals to 1 plus 1 plus 9 plus 1 plus 4 plus 1 plus 1. And that's 10, 15, 16, 17, 18. Root of 18. I hope all of you got this number.
Yes.
And
Yes, sir.
then the length of this will be what? Oh, sorry, unit vector of this. So minus x unit vector is 1 upon 18 into this vector. Uh, minus
1
y,
by root 18, right?
1 by root 18. It will be minus 1 plus I, plus
Minus 3 minus I.
yeah, minus 3 minus I,
Minus 2 minus
and
1 minus I.
that is your, this is what is uh, unit vector in the opposite direction of x, right? Okay, we'll do the next question. Yeah,
Sir, can you show the solution in the slides?
slides it is not there, that's why
Okay.
So whenever we are doing this type of problem, do we always need to write in this matrix multiplication form, or can we directly take that this one, that norm of like the distance, right? How we are doing, like first one is the first row is 1 minus I, then 3 plus I. So
That
we,
no, that is fine, not an issue. Like you don't need to vector multiplication. You're saying, right?
yes, yes, yes.
You can do like normally also, not an issue. It's like I have that habit of doing it, so that's why I do it. Otherwise,
Okay, okay.
because that way I'll feel like I will not do mistakes, right? Because I can see clearly the values. No, you don't need to do that. Like you can do like minus one plus I into that. That is fine. Like you can do this step in
Hmm.
intermediate step like this minus one minus I to minus one plus I
Hmm.
plus sorry plus minus 3 plus I into 3 minus like that you can do it, no issues. This way I will feel that okay, I will not do any mistakes while calculations because it's complex calculations, right?
Okay.
uh,
Hmm.
you will tend to do mistakes most of the times, quite mistakes.
Sir, can you scroll above next previous slide? No, no, sir. There from the solution in the yes. This is a solution, sir.
This is the answer.
From that slide, sir, can you show us
From which slide?
from website some
No, there is no solution there.
Asking
only
PPT
question?
one.
Only question is there, that's why I written there.
Okay, sir. Will this thing can be shared, sir?
Yeah, this slides I will share with you.
Sir, quiz one, all the weeks same weightage, or some week will have more questions?
Yeah, it will be different weightage. More or less same, but yeah, it will be little different.
Which week will have more weightage? Week 4 and
No,
5?
no, not like that. It will have like five will not have much weightage. Five will have the lesser weightage among week 1 to 5.
Okay, okay.
Sir, will we have any session for that also? Quiz.
Mm-hmm.
Will we have question discussing session for that?
Yeah,
Practice.
next week. Next week, revision sessions will have.
Sir, will you take those revision sessions?
Yeah, one of the sessions I will take.
Yes.
So star was same as conjugate transpose, right?
Can you repeat it again?
In question 4, we have C star. But star was same as conjugate transpose.
Okay, the option 4. Okay. Yeah, yeah. C star is conjugate transpose. Yes.
So just a quick doubt. In this fourth option, that C star, is it referring to the C matrix in the third option, or is it an arbitrary
No, no.
matrix?
Matrix in the third option.
Okay, thank you.
Sir, is it MCQ or MSQ?
I think I don't know. Whatever answer you can think of it as MSQ.
It's saying matrix, no, not matrices.
No, you can think of it as MSQ. Any maybe one or two, like that is possible. Done? Is it done?
Yes.
Okay, let us see the solution then. Uh, yes. Okay, I'll not do for everything. Can you tell me one of the metrics so that I can show you how to check for Hermitian and non-Hermitian? Anyone you can tell me, I'll solve that.
One is definitely non-Hermitian.
No,
3i.
no,
And go
let
row
me.
wise.
No, no, let me like out of these four options, right? Tell me any one of the metrics so that I can show you how to check for Hermitian, whether that matrix is Hermitian or not. And once you know that, you can do it for like others as well. Is that fine?
So the fourth one.
Fourth one. Okay.
So the fourth one, please.
First one.
Then if you, if you do like that, then it will, I'll have to solve like for all, right?
Yeah, let's do fourth because that'll cover everything, I guess.
Yeah. So let's do it for four.
For
Uh,
Hermitian matrix, A conjugate transpose should be equal to A, right?
Correct. So the definition of Hermitian is what? So Hermitian is the definition is A should be equal to A star, where A star is A conjugate transpose, right?
Yes.
So this is the Hermitian matrix. So in this case, what is C? C is -2, 1.
Is there any short method? I mean, the multiplication conjugate getting long.
No, no short method. 0 and 3. So we'll have to see that C star is a Hermitian matrix or not. But what is this C star? Okay, first of all, we'll find out what is C star. C star is C conjugate transpose, right? Or C transpose conjugate. Both will be the same. So I'll write down C star first, and okay, let's you can do it both ways. So let's say I'll do first C transpose. What is C transpose? -2 0, and then 1 minus 2i 3, right? And then I'll take a conjugate of that, and that will be my C star, and that should be equal to -2 0 1 plus 2i and 3. You can do other way around also, like first of all take conjugate and then take a transpose of it. Now this is my C star and this is my C. What will be my C star? Matrix multiplication, right? 2 plus 2i and 3. Okay. So what will be the matrix multiplication for this? That's going to be
2 plus 1 square minus 2y.
yeah, it is 4 plus uh,
1 square.
1
1.
square
1 square.
minus 4i square, so this is 5. So it is 9, right? Okay, maybe I'll write down. Okay, no issues. Write it down. So -2 into -2 is like basically, so basically here, here it is 4 plus 1 minus 2i and 1 plus 2i first element. The second element will be 0 plus 3 times 1 minus 2i and here 0 plus 3 times 1 plus 2i, and here it is 0 plus 9. So then it will be 4 plus a square minus b square. So 1 plus b square is 4i square minus b square. Here it is 3 minus 6i. Here it is 3 plus 6i, and here it is 9. Okay. Sorry. So the final is 4. Oh, sorry. Total is 9, right? This 4i square is minus 1. So
9,
that is
sir.
4. So it is 9. Then 3 minus 6i, 3 plus 6i, and 9. This is what? This is your C star. What about C star C? So what was C star? Minus 2, 0, 1 plus 2i, and 3. So minus 2, 0, 1 plus
2i,
2i, and 3. Yeah, 2i and 3.
3.
What about C? C was
Minus 2,
minus 2, 0, 1
1
plus.
minus 2i, 3.
If I do the multiplication, now this time I'll do in one single step. This 4 here, it is minus 2 times this, so it is minus 2 plus 4i. Here it is minus 2 minus 4i, right? And here that will be a square is 1, b square is minus b square is 4i square, that means plus 5, 5 plus 9, which is 14. Okay, is 14. So this is my C star C. Now what is my C star? This, right? So I'll write down here C star C is. I hope all of you got this answer. 4 minus 2.
Also,
4. 1 minute. 1 minute. Let me finish this. 4, 5, 14. So do this matrix and this matrix are same.
No, sir.
So are they
Sir, we have
Hermitian?
to check. So we have to check if both the matrices are Hermitian or not,
Yeah.
right? They are Hermitian, right?
They are Hermitian? How come?
CC star, sir, if you take
Okay,
the
okay. So
transpose, na,
okay,
what?
so you'll have to do it again. Sorry. Okay.
Yeah,
Then I okay. We
exactly.
have found out this. Okay, fine, fine. I got it.
Yes, yes, yes,
So
yes.
let us say that. Okay, can you tell me once again all the values? So CC star is what? So okay, this was the matrix.
9,
So
9.
9,
9,
3 minus
3
6i,
minus 6.
3 plus
What?
6i, and 9.
Again here.
So 3 minus 6i.
Uh,
So then 3 plus 6i and then 9.
C star C is 4.
So minus 2 plus 4i.
Okay, right. And now we have to see that whether they are
Yes.
now let us think of this as some other matrix. Let's say E. Okay, and this as, let's say, F. Now we have to check whether E and F are Hermitian or not. So how to check that? We'll have to find out its complex conjugate, and the complex conjugate for this is let's so 9, 3 plus 6i, right? Here it is 3 minus 6i and 9. And for F, complex conjugate is 4
Minus 2 plus 4, right?
minus 2 plus 4i and minus 2 minus
Minus
4. So yes, uh,
7.
they both are,
Hermitian matrices.
yeah, they both are Hermitian matrices. Okay, what about others? Let us see for this option 3, I'll show that whether, and we already have, I think, I have already calculated above somewhere. So
C is not a Hermitian.
yeah,
So it is not
yeah.
Hermitian.
So C was this matrix, and C star or complex conjugate transpose of C is this one. So you can see that they both are not same, right? This and this, they are not equal, and hence C and C star are not Hermitian. Okay, okay, and C star, C star and C star C, they are Hermitian. Done.
Yes.
Okay. So I think that's it
So I
for,
just have
yeah, yeah, tell me.
I have few doubts regarding this last one.
Mhm.
Sir, this C is this some sort of special case?
Mhm. I don't know. How can you say that is some special case?
Yeah, because if C is not Hermitian, but C star, it becomes Hermitian.
Yeah, it is there, but we cannot generalize it for other matrices, right? It's like, yeah, it is, it happened.
Is
Okay,
it?
C is not the Hermitian, but it's uh, like if you multiply with any other matrix. So let us try for, let's say, B, right? So let
B
me,
is clear, sir. B though is there. It's
yeah,
visible.
no, no, you
I'm
wanted to see
I'm
for this also, right? You
C
wanted to
just
see for B,
about the
B
C.
star and B star B,
Hmm.
whether they are
Hmm.
Hermitian or not.
Right.
So what was B? B was 1 I,
One iota minus iota.
1 I minus I, and
Write it one itself. It's one.
minus I square is
One.
plus 1, right? So B transpose conjugate, or I can say that B star,
That is
is it, so it is 1 minus I, and okay, anyway, this is Hermitian, so okay, I cannot say anything about it. This is Hermitian already. Any other matrix is not Hermitian. You can try it out, no? So take any matrix which is not Hermitian and see that whether the product of that with the complex conjugate, right?
and just could you please show it with the C?
Yeah,
Like if C is not Hermitian,
yeah.
what's so
So
special about C that makes it C star and C star C as a Hermitian?
I don't know, but like, there is, at least I cannot see that any special thing. It's kind of simple matrix, right? And if you just multiply that C with C star, you got it. One thing is for sure. Okay, okay. I think I got it. Like,
Upper triangular?
no, not about upper triangular. The thing is, I will say that, let's say if A, so you know, for real matrix, A and A transpose are what? A transpose is symmetric, right? A transpose A is
Yes.
symmetric, whether A is symmetric or not, right? Is it fine? If my A is not symmetric, but A transpose and A transpose A, they will always be symmetric. Is that fine? Hmm? Similarly, this is for real case, right? Real case. For complex case, actually we can say that A star and A star A should be symmetric, but I can say they are Hermitian. Yeah, I just forgot that property, but yeah, it is there, right? So whether A is Hermitian or not. So it is analogous, right? So in real case, we say about symmetricity. In complex case, we talk about what? Hermitian. You can see the Hermitian matrices. Let's say this matrices. Uh, you, what you can observe is the uh, so okay. Let us say they are kind of symmetric, right? Can you think of they are symmetric? Their off diagonal elements are uh, kind of equal, but
Conjugate.
they are
They
conjugate,
conjugate.
right? If I just remove that, if it was, let's say, real matrix,
Sir,
okay,
could you please just show the example? This just take the example of C and replace zero with some other element.
you can, yeah, you can actually, you can do that yourself also, right? Okay,
No,
you
just to see like is it really
yeah, yeah,
something
it is,
because of zero maybe?
No, no, no. It will not happen. Nothing will happen. You just tell me any matrix. You just tell me any random matrix. Let's say A
I
is
think
some random matrix, and we'll
3,
see that with
3,
3,
7,
7,
9,
9.
11.
This is real matrix. No, this definitely will be symmetric. Anyway, so okay, this is not symmetric, right? Okay, let me. You wanted to see for complex, or you wanted to see it for real ones? Okay, real ones.
Let's see for the real ones,
You can show
so that
definitely. Okay, what is A transpose?
we can have an analog.
3, 9,
Analogy.
7, 11. Okay,
Hmm.
I'll just be quick. So A transpose will be what? 3.
9 plus 49, that would be 58, and 27 plus 77, that will be 100, and 27 plus 77 will be 100, and 99 plus 81 plus 121. Okay. This one is 100.
100, right? 77
Other
plus
100.
100. How is it like 3 into 3,
9,
9?
9, 3 into 11, 7. No? The other
So
one, the below
it
one.
is 27 plus 77, right?
100.
First two, and how,
104.
how come it will be 100? Yeah, it is
हाँ मतलब this is the
104.
104, sorry, 104. The other one will be
104
104.
and 81
Doesn't matter.
and 121,
Doesn't
right?
matter.
So 202. So it's symmetric, and similarly, A
Hmm.
transpose A also is symmetric. Let us talk about
Right.
complex also. It will not be symmetric, but it will be Hermitian. The difference between symmetric and Hermitian is what? Like the off diagonal elements, they will be, they will the coefficient of real and complex, they are same. The difference is the signs are different. Okay, but let us check our hypothesis there. Let's say it is 3, 0. You say I and 5. Is this a Hermitian matrix? A?
It's non-symmetric, I think, but yeah, we can try for
Is it Hermitian?
Hermitian. No, it's not Hermitian.
Sorry, okay.
It's not Hermitian.
Because the A star will be what? 3
3 minus
minus
iota 0, 5.
5. Alright, so that means it is not Hermitian definitely. But what about A star? A star is 3, 0, I, 5,
9,
and 3 minus I,
9
0,
minus
5.
3,
So it will be
3,
9, uh, what is it? 15, and here it is. Oh, sorry, not 15.
minus 3 iota,
Minus 3 I.
9 minus 3 iota, 3 iota, and 25.
And
25. 25.
not 25, 26.
Sorry, 26.
So is this a Hermitian matrix? A
Mm,
star? A star is Hermitian.
right.
How can you check that?
Also,
So this will become 9,
3 iota.
3i, 3i,
Yeah. 20.
star, complex transpose. Is that fine? So it will always be there. You can
So
check for A
it's,
star A also.
so it's a general property, right?
Yeah. So it's there in real case. Real case, what is the property? If A is symmetric or
8.
not, it doesn't matter. A transpose A and
Right, right.
A transpose are symmetric,
Symmetry.
right? Similarly, in case of
And
complex
also equal?
matrices, not equal. A star and A star A are they cannot be equal, right? Because uh, let's say your A matrix is 2 cross 3, then its A transpose will be 3 cross 2, right? And I think when A transpose, right? And then in other case it is A
2
transpose
cross
is 3 cross 2, and A will be
2
2
cross 3.
cross 3. So the multiplication of these two will give me
Different.
2 cross 2 here, and here I'll get it
3
3
cross
cross
3.
3. So they cannot be equal, right?
Right.
Understand? Okay. So I think that is it for week 5. I wanted to showcase week 4 also, but there are like 10 questions. Uh, do you want me to discuss some till maybe 9:30, and then we can stop?
Yes, sir.
Okay.
Sir, can you explain the first option here in this question? Like A. Yes, sir. This one. Is this the Hermitian?
It's easier, right? Okay, I'll show it on like
Yes.
this. Can you
Yes.
tell me the matrix? Now, let's quickly do it.
Sure.
Row wise,
3.
tell the row wise. 3
Yeah. 3i.
I
2 plus I.
2 plus I
Minus I.
hmm,
Minus 2.
hmm,
Minus 7.
minus 7.
Yes, sir.
Hmm,
Minus
2 minus I.
hmm,
7 into cos pi.
hmm.
1.
So its A transpose will be 3
so first.
minus
So
I.
before proceeding,
Hmm.
excuse me, before proceeding, just solve this 7 cos pi so that it simplifies.
No, it doesn't matter. No, it's constant. What do you have to? I can just keep it as it is. No, I'll
I
keep
mean,
as it is. We don't.
that's the
We know that
confusion.
it's some constant. Uh,
7 cos pi is minus 7,
cos of pi is, yeah. Cos of 180
minus
is,
1.
yeah.
So,
Like,
so write it like that, no? So that it simplifies.
okay, but anyway, this like here it will not. This fine. Okay, it's fine. What will be? Oh, sorry, I think there is some mistake now. 3. Okay, that row will become that. Okay, that's correct. So it's 2 plus I minus 7 and 1. Is that fine? This is A transpose.
Hmm.
Now A transpose conjugate will be, it's your A star, and A star is
Same.
3 plus I,
I 2 plus
2
iota.
plus I,
Minus I,
minus I,
minus 2, minus 7.
minus 2, minus 7,
2 minus iota,
2
minus
minus
7,
I,
1.
minus 7 and 1. Is the same as that of A?
Same.
Is that equal to A? Yes.
Yes, it is.
And hence A is,
Yes, sir. Initially, I didn't convert that 7 cos pi, so I got doubt.
no, it is
That
okay. It is okay. It is okay. So if you don't convert also, what will happen there? Okay, that's why you said like you are not able to identify it. Huh?
Yes,
That's
yes.
okay. Fine. Done. Is that fine?
Yes, sir. Thank you.
Okay. So just 2 minutes. We can start. Uh, or shall we skip like week 4? Week 4 is fine. If I can skip that one.
So someone has
Are you
raised
sure?
the question regarding week 4, P 14 question, I guess.
Can you tell me the question? Then I can
Week
solve that.
4, PA 14 question.
Sir, could you do some questions in week 4 also, sir? It's better for us.
Okay, I'll do that. So I may not give you the time to solve here, possibly, right? So that we can cover majority of the question. I think that will be fine.
Yes, sir. That will be fine.
Hmm. So yeah, like, can any one of you just uh, complete this? Oh, I opened the same one. Huh?
So do we also have to join?
No, okay, no issues. I'll just solve for you. What about this question? Let me do one thing.
Excuse me, sir.
Huh.
Actually, I have a problem with week 3, sir. Projection, least square method, and all. Can you suggest something to watch that?
I think when one of the Solvidus sessions, I think I have explained it in detail. If you can watch that, that will be good. And if you don't understand after that also, uh, maybe you can watch one. There is a good resource, Linear Algebra by Gilbert Strang. If you know the name, I think he is
Yeah.
the like best person in this linear algebra thing, right? So you can just watch his lecture on the least square method. It's like very good lecture. You will get to know from there. So I also have studied from there. So you may wanted to watch that. And if you after that also, if you have any problems, let me know. I'll explain it. Fine.
Yeah, sure. Thanks.
So yeah, just try to solve this one. I'll come back in 2 minutes. Fine. Okay. So shall I solve this? So how when the matrix will become singular?
When
So
determinant is
when the
0.
determinant is 0,
Do you think that determinant is 0 here by looking at this matrix?
that's what we have to find out.
Okay. There is.
We can check for for what value of x, two rows or two columns. They can be linearly
Uh,
dependent.
First, we
So
can
I'm not sure.
subtract third column, 2 times third column from the first column. That will give us 8, 0, 12, and then
So
This
your
will
1 minus
not be 0, right? The
first column
takes.
minus,
so A is
but
what?
x equals
Okay.
4, it will
Okay.
be
It's like okay. The simple thing to do is 8x0
0.
and 402 402 and we have 1260, right? 12 6
Or
and
we can
0.
expand it
So
using 2.
yeah, determinant of let's say like with the simple we know what we can do. It's 8 into 0 minus 12. Sorry, not plus. It's minus 6 into mm, 0 minus 24 plus 0, right? So it is minus 96 plus 24x, right? And the matrix A is called as singular
The determinant.
when determinant of A equal to 0. So we have asked that what is for what value of x the matrix will become singular. So that means it should be equal to 0, and in that case you will have 24x equal to 96, and that will give me x equals to 4. Right? Right?
Right.
Okay. Fine. That's how you can do it. You can solve it for. Maybe you can do the next question. The next question is the eigenvectors of the matrix are written in the form of 1a and 1b. What is the value of a plus b? That is what given to me. So let's say if you have any matrix A, right? What eigenvalue, eigenvector equation they that will solve? It will be like ax equal to lambda x, right? This is the eigen equation, right? And where x is what? Eigenvector corresponding to corresponding to eigenvalue lambda. Is that fine? This is what we know, right? Uh, we already know that for this matrix, the eigenvectors are 1a and 1b. Is that fine? So what is my matrix A here? 1, 0, 2, 2. What are the eigenvalues of this matrix? 1, 2. Why? Because this is upper triangular matrix, right? The eigenvalues of the upper triangular, lower triangular, and the diagonal matrix are the
diagonal elements.
diagonal elements. I hope all of you know that. And if you don't know, let's say if I don't remember that property, what should I do then? I will
Characteristic.
I will find out this characteristic equation and find out the determinant of that and equate it to 0. So what
0.
is a minus lambda I? A minus lambda I is 1 minus lambda 2, 0, 2 minus lambda, and we'll have to find out its determinant and equate it to 0. So it is 1 minus lambda into 2 minus lambda
Minus
equal to 0, and that will give me lambda equals to 1 and 2, right?
Sir,
If
could you please repeat that property you said for
The
upper and
property is that, let's say, for if you have upper triangular or lower triangular matrix or diagonal matrix. You know diagonal matrix? What is diagonal matrix?
Yes.
only diagonal
So
elements
all
are
elements,
not
Elements are
all elements 0 except
all
diagonal
elements except the
elements
diagonal elements are 0.
are
Okay.
0.
And for these special matrices, the diagonal entries, right, or these elements, they actually represent the eigenvalues.
Eigenvalues.
Okay. One more property you should remember always is trace of the matrix should be equal to sum of what? Sum of eigenvalues.
Diagonals.
That is there, but trace is like you'll have to trace is like sum of all the diagonal elements, right? That should be equal to sum of eigenvalues. Another property is uh,
Determinant is
product or okay, product of eigenvalues equal to determinant of the matrix. Okay, these properties are like they frequently come in, so you may remember it, like you can by heart it. Okay. Okay, so that's fine. So I got the eigenvalues. What other information I am having in this question is that 1a and 1b are the eigenvectors, right? For this matrix. What can we say about that? Those eigenvectors, or okay, what can you say about it? So a x equal to lambda x, right? Okay. So suppose you are, and in this case the eigenvectors are 1a and 1b. So actually I don't know this eigenvector is corresponding to eigenvalue 1 or 2, or this eigenvector is corresponding to 1 or 2, right? But see, the first element in both the eigenvectors is 1, right? So let's say I assume that 1a is the eigenvector corresponding to the eigenvalue 1, and 1b is the eigenvector corresponding to eigenvalue 2. I'm assuming that because it does not affect anyway the why it does not affect, because both of them are actually having the first element as 1. So my 1202 into 1a equals to 1 times 1a. So this equation it has to satisfy because lambda is 1. Let us say for lambda equals to 1 I am talking about. And what this will be then? So this 2 cross 2 matrix, this is 2 cross 1. So I'll have what? 1 and sorry, 1 plus 2a and 2a. That should be equal to 1a. Is that fine?
Yes.
I'm doing anything wrong here?
It's fine, sir. A becomes 0.
A equals 0? No, right?
Yes, A will be 0.
Huh?
A will be 0.
How come A will be 0?
It's coming 0
No,
first.
1 plus 2A equal to 1 and 2A will be A. 2A is equal
Ah,
to A, right? It will be only
ah.
possible when A
That's
equals to B.
consistent. That's only cost also consistent with the second equation also. Two ways.
Yeah. So let's say, yeah, correct. So equal to 1, sorry, equals to 0, and anyway A equals to 0, and this is only possible when A is equals to 0, right? So the first is 1 0, right? First, and I have found out that A equal to 0. What about the second? 1b equals to 2 times
Two times
1b,
1
then it will be again same,
1 plus 2
plus,
and 2
so basically it is 2 here, 2 here,
so
and plus
1
2
plus
plus
2
2,
b
and here it is 2b equals
2
to
b
0.
0 mm,
So b equals to 1, right?
b plus half
uh,
no
right, so
Half, half.
1 plus 2b equals to half,
half
half, and here, okay,
same half is half
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 also
into
will
half is
suffice,
half.
right? Here, yeah.
So sum is half.
Okay, half will be there, and then we need to find out a plus b, which is 0 plus
Half.
half is to 1. Okay, let's see the another question. Uh, if the matrix is orthogonal, then the value of x is what? That is the question.
Uh, so
Yeah.
in the previous question, can we assume that the vectors, eigenvectors, can we take any lambda values like for the first one, the 2, and for the second one, 1?
Yeah, you can take, and it will give me the same answer. Why? Because that is its first element was 1, right? That is possible.
Okay.
It will be minus 4 by 4,
So
right?
can you please show the solution for the previous question?
So you
Okay.
basically solve for this, no? This equal to this. Then you'll get
Yes.
a equal to 0, and then you can solve for 1 plus 2b equals to 2. Then you'll get the b's value as half, and that will be like that will this value will actually suffice for that part also, right? Means these two equations will be correct if I plug in those values. Okay, so if the matrix is orthogonal, then the value of x is what? That is the question. So when the matrix is orthogonal,
And the norm is 1. Norm of the column vectors are 1 as well as they are orthogonal to each other.
The dot product is 0, no?
that
Yeah,
is for
so the
vectors, no? That is for
Okay.
yes,
vectors, right?
vectors,
Hmm?
yes.
So A transpose is
So matrix is orthogonal
identity.
when it's
A
yeah,
transpose dot A equal to I.
yeah, or the other actually the way you said, no, dot product between them is 0. That else
Yes.
is fine. Dot product between these two vectors should be 0.
0. Yes.
So basically, the matrix, when I talk about matrix A, the matrix A is orthogonal when A uh, or A transpose A should be equal to I, right? Then that is or A transpose, basically you can say, right? That should be equal to A. Okay, that's correct, right? Hmm?
Yes, yes.
And or the columns of matrix A are orthogonal. What does that mean? Let's say C1 and C2 are the columns, then C1 transpose C2 should be equal to 0, right? I hope all of you are with me.
Yes, yes.
Okay. Good. So our matrix A is what? Here it is 3, 4, 3. Okay. 5, 5, 4 by 5, x, and 3 by 5. And we know that it is orthogonal. So I use this part to check. So let's say this is C1, this is C2, and I'll say that C1 transpose. So C1 transpose 3 by 5 x C2, that should be equal to 0. So let's try and calculate. So it is 12 by 25 plus 3x by 5, which is equals to 0, right? Um, or I can say that, okay, 12 by 25 equal to minus 3x by 5. This 5 will be here, 4 will be here. So x will be what? Minus 4 by 5. All okay?
Yes.
Yes, sir.
And a different and one more way to check this out is, so my matrix A was 3 by 5, 4 by 5, minus 4 by 5, 3 by 5, and it's, so we said no A transpose. What is A transpose here? 4 by 5, 5, 3 by 5. What is the multiplication? 9 plus 16, 25 by 5. It's 5, 5 here, right?
Sir, is it skew symmetric matrix?
Check it out. Tell me the answers. No?
It's 1, right?
No,
1.
3 3 the 9. 9.
9 plus 6, 9 plus 16 by 25, right? 25 by
5.
Oh,
25.
yes.
The
Yeah,
other
yeah.
one
So,
is
1.
okay, should be 1. Yeah. 1.
0.
Here it is 0. Yes.
0.
So it is identity matrix. So, and I think you can check for A transpose A, that also should come out as identity matrix, right? I hope you understand the definition of orthogonal matrix. One more thing is what?
so this
Uh,
is
one more property of this is what?
Norm is 1.
Norm of A,
Norm of the
all the
column
vectors.
vectors.
Yeah, should be equal to
this
1.
one.
Correct. Hmm? Because you can check
And so these are
square of this. You take the square root of it. Yeah. Yeah. What is your doubt?
so this skew symmetric.
Which one? Which is skew symmetric?
A mat.
Yeah, yeah, yeah. A matrix, no? Yeah, here it is. Yeah, skew symmetric.
So if it's skew symmetric, the AAT will always be one
Yes, yes,
identity.
yes, yes.
That's the property.
Correct. Yeah. That is true.
So we can check, right?
Sir, it
Without
is
having
not.
any calculation.
What happened?
It is not skew symmetric.
It is skew symmetric, right?
No, diagonal elements will have to be zero. Then.
Yes, yes, sir. Yeah, yeah, yeah. Sorry, sorry. Yes, correct, correct. Good catch. Yeah. Diagonal elements should be 0. Yeah, correct. Okay. Shall we go to the next question? For the matrix A, the eigenvalues are 4 and 8. Calculate x plus y. Okay, shall we solve this? It's good question, and we will use like some properties here. So what is A matrix? 2, 3 x y square. And what are the eigenvalues for this matrix? 4 and 8, right? 4 and 8. Is that okay? Hmm? So what are the properties I told you? The trace of A should be equal to
Sum of eigenvalues.
sum of eigenvalues. So by that, what is the trace of matrix A? 2
2
plus
plus
1,
1.
which is equals to 4 plus
12.
8. Equation 1. And what is the second thing I said? The product of, or okay, I'll do one thing. I'll make it consistent.
Det of A equals to product
Yeah.
of eigenvalues.
Yeah. So determinant of A should be equal to product of eigenvalues. So it is what do you think about it? So what is the determinant of A here?
2y
2y
2i
minus 3.
minus
3x equals to 4 into 8, equation 2. So what is my first equation? 2 plus y equals to 12. So what I'll get from equation 1? From 1 I'll
10.
get y equals to 10, and from 2 it is 2y minus 3x equals to 32. This from 2 to 2 into 10 minus 3x equals to 32. So 3x equals to 20 minus 32, which is minus 12, which gives me x as minus 4. And what we have asked here, calculate x plus y. So minus 4 plus 10, which is 6. Done?
So if we like multiply the matrix by any scalar initially,
Uh-huh.
so will it affect the end results if you
Yes,
divide that by
yes,
anything?
yes. Because your eigenvalues will get multiplied, right? So let's say the eigenvalues of 2A matrix are what? 2 into 4 and 2 into 8, right? So the sum will be different, and now what will happen? The product will be different, right? I don't know. Maybe I think here also, if you think about it, it's the trace will become 2 times this. Here it is 2 times this, so 2 times this. Again, 2 will get cancelled. This equation remains same. What about this? It is 4 times this. Here it is 2 times this. Yeah, it will change, right?
Like if we multiply and divide, if I multiply and divide by 2,
Then what is
that
the
doesn't make that
what is
don't
it
make
like?
any sense.
Multiply and divide by 2 is like same matrix, right?
No, but I'll be able to like calculate it using that the. I was trying to just make it equal to the eigenvalue because it's a 2 cross 2 matrix, no? So
No, if you
it might.
multiply with 2, what will change, and if you divide it by 2, what is the difference?
Yes, I got it, got it. That is in the case of triangular matrix, upper triangular, lower triangular matrix.
Yeah.
Got it.
Okay, let's solve this question, and maybe I can just okay. Let's see. I can do continue for 5 minutes more. And I'll stop. Let A be a 2 cross 2 matrix with all these elements. Eigenvalues of A to the power 18 are what? What is matrix A here? All ones,
1 minus 1.
right? Because A to 2 element is minus 1, right? We need to find out the eigenvalues of here,
In power 18.
eigenvalues of
A power
okay. That is the question, right? So what are the eigenvalues of A here? I can do one thing. I can solve the
Plus
equation
minus
lambda 1 plus lambda 2 equals to
0.
0. Lambda 1 into lambda 2 equals to
minus one.
minus
minus
2.
1, right?
Minus
Why?
one, right?
Determinant
Determinant
minus
है ना
1.
-1 minus 2
What is the determinant of A?
Acha, sorry.
minus
Minus
Minus 2, right?
Minus two. Minus two. Okay, okay.
So that means lambda 1 equals to minus lambda 2,
minus
and then if I
lambda
substitute here, so minus lambda 2 square equal to minus 2, so which gives me lambda 2 square equals to 2, which gives me lambda 2 equals to
root
root of 2, and then lambda 1 equals to minus 1.
minus root
Hmm? Okay, so now what are the eigenvalues of, so eigenvalues of a to the power 18 are lambda 1 to the power 18 and lambda to the power 18. So basically I can think of like this: minus root 2 square power 9, right? So this is 2 to the power 9. Hmm? uh, and I think both of them are the same, right? hope you understand this part. If not, let me know. I'm assuming that you know these things. I'm doing the same thing right here. It's to the power n. So the eigenvalues of lambda to the power 18 are same actually. They are 2 to the power 9 and 2 to the power 1. Then
Sorry, a to the power 18 and lambda to the power 18 both are the same, sir. How?
it is possible, no? The matrix can have the same eigenvalues, right? Why not? So I'll show you one matrix. Let's say 1 1 0 0. What are the eigenvalues of this matrix? 1 1, right? The eigenvalues of the
Hmm.
matrix can be same or can be different,
Yes.
or you can just think of this matrix also. What are the eigenvalues? Same 1 1. And take any matrix. I'll not.
Sir, how are you finding the eigenvalues here, sir, in these type of matrices?
I
Like
told you.
just, yeah, by
You can
using
solve.
properties, right?
Yeah, you can solve otherwise also. No issues. Like if you wanted to solve it by using the first principles, it is possible. Like where are we?
Okay.
Just a minute, I'll show you. You know how to solve this matrix. Which one I should solve? Shall I solve for this? So 2
Yes.
0 5 2. This is my matrix A. So first of all, I need to find out its eigenvalues, right? And that is my goal. So first of all, I'll find out this polynomial equation. What is that? Not polynomial equation. This matrix A minus lambda I. So that matrix will be 2 minus lambda 0, 5, and 2 minus lambda. Now, determinant of that matrix, I have to equate it to 0. So determinant of this matrix is 2 minus lambda to 2 minus lambda minus 0 equal to 0. Okay. And then that means what? Lambda equals to 2 and 2. Correct, right? Or if you don't know that also else. So it
Yes.
is like, you know this, right? Or you can solve like 2 square, which is 4 minus 2 lambda minus 2 lambda plus lambda square equal to 0. Then what you do, so lambda square minus 4 lambda plus 4, that is your quadratic equation. And how to solve the quadratic equation? So the coefficients are a equal to 1, b equals to minus 4, and c equals to plus 4. And the roots of this equation are minus b plus minus root of b square minus 4ac by 2a. And then it will be like minus b is what? Plus 4 plus minus root of b square is 16 minus 4ac is 16 and divided by 2a is 2. So basically you will get 4 plus minus 0 by 2, and that means 2 comma 2, right? Because it should have two roots. If the polynomial is in quadratic, right? So it should have two roots. That's, and basically it's not having two
Yes.
roots. It is the same root, but we are writing this for two times. And that's why the eigenvalues are same. Okay.
Yes. Thank you.
Okay. Let's. Okay. Maybe I'll do one question and we'll stop. The value of p such that the vector 1 2 3 is an eigenvector of the matrix 4 1 2 p2 minus 1. And how will you do that? This, how will you solve this question? We'll have to solve. I think it's there is no shortcut to this. The value of p such that the vector is an eigenvector of the matrix.
To solve it.
I think we'll have to solve this like the equation of eigenvector is what, or what is eigen equation? This is, so what is matrix A? It is 4 1 2 P 2 1 P 2 1 and 14 minus 14. 14 minus 14.
We can do one thing, right? Dot this matrix into 1, 2, 3 is equal to 0, right? We can equate
Huh?
this matrix into this vector will be equal. Yeah, okay, lambda is.
That will not be 0, right? So I don't know
Yes,
what lambda here
right,
is.
right.
We are saying that some lambda.
Uh-huh.
So
That was a minus lambda, sorry.
right. So what is this? 4 plus 2 6, 6 plus 6 12. Here it is P plus 4 plus 3, which is 7, and 14 minus 8, which is
36.
6. 6 plus 30 36, and that should be equal to what is
Lambda,
it,
2 lambda, 3
lambda,
lambda,
2
2
lambda
lambda, 3
and
lambda.
3 lambda. So by equating, so I'll get lambda equals to 12, right? Or like from first also, and from the third also, you get lambda equals to 12. Now I know lambda equals to 12, that means P plus 7 equals to 24, right? 2 times lambda. That gives me
70.
P as 70.
70.
That's how you have to solve this.
So these type of questions will appear in the quiz
Yeah,
one, right?
similar kind of questions. The thing is, you know the basics. So you see,
Right.
you should know what is eigen equation. You should know what are the determinants. Maybe few properties. If you know, it will be better for you. That way, mostly it will be like easier to solve. Like, this kind of questions will be there. Nothing more different.
Right.
You can actually refer the previous year questions also. So how they have asked, and you will get some idea about it. Okay, so I'll stop here.
Correct.
There are like 3 4
So
more
just
questions are remaining. Maybe we can discuss it later.
so
Yeah.
sorry to interrupt, sir. Just the previous question before this, the fifth
Okay.
question. I had some.
Uh,
My network was actually a bit
this one, yeah.
previous prior to this. Yes, sir. This one.
The property, right? Eigenvalue properties. So
Yes, sir, that you have calculated, right? The values.
yeah, yeah.
Even
But
root 2 and minus root 2.
yes, that I have calculated separately, and then we have multiplied. So but
After that, how did you proceed?
after that, where these are
The
this
question
is the answer,
A
no?
power A power 18.
A power 18. So the answer is this, no? 2 to the power 9 and 2 to the power 9. A power 18 is like, okay, that's what I wanted to tell you. Okay, so I'll write down 2 properties. You can understand that better. So 2 or 3, I don't know. So let's say if lambda 1 and lambda 2 are the eigenvalues of A. Okay, fine. Then lambda 1 to the power n and lambda 2 to the power n are the eigenvalues of A to the power n. Got it? So n can be any real number. Is that fine? So
Yes.
let's say 2 and 4 are the eigenvalues of A. Then what are the eigenvalues of A cube, 2 cube,
Cube of
and
individual
2 cube?
item.
Like that. So previously we have found out the eigenvalues for A, which were minus
Root
root
2
2
minus
and
root
root 2.
2.
We need to find out the eigenvalues for A to the power 18. So they are minus root 2 power 18 and root 2 power 18.
Okay.
So what I did is I just like
Half power gets cancelled. 2 power 9 2 power.
and then I have did it like this,
Square of
right? And that's and minus root 2 square is 2, root 2
2.
square is 2, and 2 to the
2.
power 9 it will be remain. That is one property. Another property is if lambda plus 2 okay, sorry, lambda plus 2 and sorry lambda 1 plus 2 and lambda 2 plus 2, let's say, are the eigenvalues of A plus 2.
Okay.
So if you have A plus C,
2 or 2i? I guess it's a plus 2I.
Oh, a plus 2I, sorry, yeah,
In that a plus 2.
yeah, right. So here it's lambda, okay, ci, and lambda plus c, lambda 2 plus c. This is generalized version, right? C is any constant, any scalar, and I is identity.
Identity.
Okay, and by using this, you can solve any question.
So you'll be sharing this PDF, right? This note.
Which one?
This note,
You wanted this,
whatever
huh?
you have.
You, if you want, I can share, but I don't see. I haven't written it like properly. If you want, you can. I can share it in the this. You know what? Calendar only. I will attach to that calendar. You can download it from there. Okay.
Right.
I hope this is fine.
Yes, sir.
Okay, let's close this.
Yep.
If you have any doubts, and somebody has asked me one question, right? Maybe okay. What you can do is maybe share that question with me. Maybe post it in discourse. You can tag me. I'll write down answer. Or else we'll see you it in the next session. Okay.
Right. So before, yes, sir, the session was totally enjoyable, sir. Before leaving, sir, may I know your good name?
Huh? Mayur. Mayur.
Before.
Okay. Mayur.
Sir, did you
The
take the
session was
last
enjoyable, sir.
MLF also?
Sorry.
Did you take the MLF last time also, sir?
Yeah.
The
Yeah.
MLF.
Yes. Yes. I was. Okay, and I know like some of you might be in MLT. I'm just taking MLT also this term. So yeah. Okay,
Sir,
fine. Yeah.
sir,
Yes. Yes, sir.
in week 5 graded assignment, in the first question, it seems that none of the options are correct.
Okay, so you can just write an email to me, no?
Okay,
Uh,
what
maybe
is your email, sir?
yeah, I'm writing it in the chat box. You can write to me.